Assalamu alaikum. Acceleration. What do you mean by acceleration? If the velocity of the object changes, so the object accelerates. The velocity is a vector quantity, has magnitude and direction. So when the velocity changes, if the value of the velocity changes, increases or decreases, or if the direction of the velocity changes, then we say the object accelerates. For example here, if we have an object, a car for example, move in this direction and the velocity is 5 meters per second, and then it becomes 10 meters per second. So we say the object accelerates. If the object has 5 meters per second, but the direction changes, so also the acceleration exists. So the acceleration exists if no change in magnitude of the velocity but change in direction, or if change in magnitude and the same direction. So the velocity, if the velocity changes, it means the magnitude or direction changes, acceleration exists. But what is the definition of acceleration? Acceleration is the rate of a change of velocity. Rate of a change of velocity. So it means the change in velocity over the time taken. Acceleration denoted by a small. SI unit of acceleration, we will explain, it's meter per second squared. Acceleration is a vector quantity. Now, remember from the definition, the acceleration is the rate of a change of velocity. So it is the change in velocity over time taken. What do you mean by change in velocity? It means the final velocity minus initial velocity over time taken. Let us see this example. If the car has acceleration at the point A 2 meters per second and its velocity at the point B is 10 meters per second, and that change in velocity in 4 seconds. So what is the acceleration? The acceleration equals the final velocity, which is 10, minus the initial velocity, it's 2, over the time, which is 4. 10 minus 2, it's 8 meters per second over 4 seconds. 8 divided by 2 equals 2. So the answer is 2. 2 meters per second over second. So it means B meter per second squared when we move second down. So the unit of acceleration is meter per second squared because it is unit of velocity over unit of time. So meter per second, it means meter per second squared. Another example. Look at this. A car has velocity at B 10 meters per second. And at the point C 4 meters per second, and the time of that change is 2 seconds. So what is the acceleration? It is the final velocity, which is 4, minus the initial velocity, which is 10, over the time taken, which is 2. 4 minus 10, negative 6. Remember, we don't say the difference between velocity. No, it is the final velocity minus initial velocity. Over that time, negative 6 over 2, negative 3 meters per second squared. If the acceleration is negative, it is called deceleration. So the answer of this example, we can say the acceleration equal negative 3 meters per second squared, or the deceleration is 3, because deceleration means negative acceleration. Don't say the deceleration equal negative 3 meters per second squared. No, the deceleration is just 3 meters per second squared. Now the formula for the acceleration is V minus U over T. A is the acceleration, which is vector quantity. Its unit is meter per second squared. V is final velocity. It's meter per second. U is initial velocity. Its unit is meter per second. And T is the time taken. It is in second. So remember, the deceleration is negative acceleration. We have two types of acceleration: uniform acceleration and non-uniform acceleration. When we say the acceleration is uniform, if the velocity increases with constant rate. For example, look at the first example. Down is the time in second, 1, 2, 3, 4, and up the velocity, 5, 10, 15, 20, and so on. So at the first second, it's 5. At the second, it is 10. At the third second is 15, and so on. What do you notice about this velocity? Here, you note that the velocity increases with constant rate, 5, 10, 15, 20, so increases with 5. So here the velocity increases with constant rate. So we say this is uniform, what? Uniform acceleration. So this is uniform acceleration because constant rate of change. But look at the second example here. The velocity at the first second is 5, at the second is 10. So the difference is here 5 increased by 5. At the third second it's 12, increases by 2. And then 18 increases by 3. So this is not constant rate of a change. So the velocity increases but without constant rate. So this velocity, this acceleration is called the non-uniform acceleration. So we have two types of acceleration. Uniform acceleration, it means the constant acceleration, and the non-uniform acceleration means not constant acceleration. What is the difference between them? In uniform acceleration, the velocity increases with constant rate, بتزيد زيادة ثابتة each time. But in non-uniform acceleration, the velocity increases with non-constant rate. يعني بتزيد زيادة بس مش ثابتة، مش كل 1 second بتزيد نفس الزيادة. So this is the difference between uniform acceleration and non-uniform acceleration. Now let us see past paper questions about this. Look at this question. The table shows the reading on a car at 5-second interval. So this is the time 0, 5, 10, 15, 20. So the time increases. And this is the speed in kilometer per hour, 0, 30, 50, 60, 65. So what do you notice? The speed increases. So if the speed increases, it means change in velocity. So it means acceleration. So which row describes the speed? The speed increases. And the velocity is not 0. We have velocity. So the answer is D. The speed increases and the acceleration not 0. Look at the next question. A train accelerates from rest. From rest, it means the initial velocity is 0. So write the given u equals 0 meter per second at constant rate. So it's uniform acceleration along a straight horizontal track. So this is called the linear acceleration, linear uniform acceleration. It reaches a speed of 24 meters per second. So this is the final speed, 24 meters per second in 60 seconds. So the time of this change is 60 seconds. Calculate the acceleration. So we need the acceleration. What is the formula that we can use? Remember, A equals V minus U over T. So this is the rule that we can use. So we continue. V is the final velocity, which is 24, minus U, initial velocity 0, over time 60. 24 minus 0 is 24. 24 divided by 60. The answer is 0.4. What is the unit? Remember, it's meter per second squared. Unit of velocity over unit time, over unit of time. So it's a meter per second squared. This is acceleration, okay? Yeah, because it's positive. Now, the next question. A runner accelerates from rest. From rest, it means that the initial velocity is 0. with an acceleration. In that question, we have the value of acceleration. A equals 4 meter per second squared for 2.3 seconds. So the time is 2.3 seconds. What will be here? Speed at the end of this time. We need V. Remember that formula of acceleration, A equals V minus U over T. How many unknowns in that formula? 4 unknowns. If they're given 3 of them, we can get the fourth one, like this. So we do substitution. So A equals 4. V, the final velocity, we need it, so it's V, minus U, 0, over the time, 2.3. Now, we write 4 equals 4, V minus 0, it's V, over 2.3. How can we solve this equation? This is called the equation. How can we solve this? We can do this as ratio, so we do cross multiplication. To get V, it's direct. 4 multiplied by 2.3 divided by 1. So from this, by using cross multiplication, so V times 1, it's V. V equals 2.3 multiplied by 4 over 1. 9.2. This is what velocity. Its unit is meter per second. Another question. A car can accelerate at 5.6 meter per second squared. So we have the acceleration of the car. So A is given 5.6 meter per second squared. Starting from rest. Oh, not all the objects start from rest. Sometimes they start at a speed. So, but here starting from rest, it means the initial velocity equals 0. How long? How long? It means we need the time. So in that question, the time is required. It takes to reach speed. So we have here the final velocity, 24 meter per second. Remember, we write the formula in each step. So the formula here for acceleration, A equals V minus U over T. The second step, substitute. A equals 5.6 equals V is 24 minus U is 0 over T. Now 5.6 equals 24 minus 0, it's 24 over T. We do the same way like before. We do cross multiplication. How can we do cross multiply? We write this over 1 because 5.6 over 1, it is the same. And then if we need T, we do cross multiplication. So 24 multiplied by 1 divided by 5.6. So T equals 24 multiplied by 1 divided by 5.6. So the answer is 4.3 approximately. So 4.3 seconds. I hope you understand this topic. Thank you.